Okay, so now let's look at the last three examples here. Ratio test and root test to determine whether series converge or diverge. So ratio test and has a name, right? Root test. These are two very powerful tests to check whether series are divergent or convergent. And that's also the criterion here. So what it says is if capital L is less than 1, so it's not only convergent, but it's also absolutely convergent. So it's an even stronger statement. Capital L equals 1, inconclusive. Okay. Capital L is greater than 1, divergent. So that is the ratio or root test. Okay. Yeah, so let's use this test to work on some problems. Okay, trying to save some space. Number 18. AN is here. Okay, so n plus 1 is going to be n plus 1 factorial e to the power negative n plus 1 over n factorial e negative 8n. Take the limit as n goes to infinity. I did not put the absolute value sign because this term is a positive, so no need. So after you simplify, so you're going to have n plus 1, right, times e to the power of negative 8. And it turns out that this is a constant. As n goes to infinity, this goes to infinity. So this definitely is greater than 1. Hence, diverge. Okay. 19. So let's see if I can get another paper with a little bit more space. Right here. So 19, our an plus 1 is going to become into 2, right? N plus 1 factorial, so n squared, over 2 times n plus 1 factorial, that's an plus 1, over an, which is times the reciprocal of it, which is 2n factorial squared over 2n factorial, right? So for here, n plus 1 factorial, so first of all, this 2 and 2 can be cancelled. So on the bottom, so this is going to become into n plus 1 factorial times n plus 1 factorial over 2n factorial. This, keep in mind, this is 2n plus 2 factorial, right? So it's going to be 2n plus 2 factorial times n factorial and factorial. So just to split the square into itself. So now you can see that n plus 1 factorial over n factorial, it will give you n plus 1. Okay. Now we have here it's n plus 1 times n plus 1. Okay. Right. So those two split. Now 2n plus 2 factorial equals 2n factorial times 2n plus 1 times 2n plus 2. So, after this simplification, this have 2n plus 1 left and 2n plus 2 left. So if we take the limit as n goes to infinity, turns out that this is very easy to compute, right? So it's just n squared over 4n squared, so it's just 1 over 4, so it's less than 1, hence the series converge. Okay, cool. Very last one, this limit. It asks us to use the root test. we can just write on this paper here. So it's gonna be limit when it's starting from 1, this is 0, this is 0, this is 0. But when it's starting from, when n equals 1, ln n over 9n minus 10 is 0. When n is greater than 2, you see all the inside of this part is going to become into a positive. So we're good. So the nth root, and then times this n, so it's just becomes into ln n over 9n minus 10, right? Minus 10. And remember that this limit, remember that ln n is less than n, right? Is less than n. In other words, as n goes to infinity, this part will become 0, right? Will become 0. So this is all. And then when this is 0 here, what we can get? Well, we can get that this is inconclusive, right? This is inconclusive because we get the C2. Oh, excuse me. I need some coffee. When this capital L is 0, it's definitely it's less than 1. So we're good to go. So this is converted. Yeah, right? So that finished the whole story. Okay, yeah. Okay, so hope you enjoy this video, and again, happy learning. Thank you.